Hi everyone, this is Ayush Jaswal and I am making an explanation video of internal test, second internal test of data science on deep learning section C, where deep learning uses neural networks with multiple layers to learn hierarchical representation. It is behind many recent AI breakthroughs is in vision language and game playing. Our question 23 is a model trained once and not updated further is a static model. Where static models are trained offline once and deployed without updates, they are simpler maintained but may become outdated as data distribution changes. Now our question 24 is a model that continually retrains with new data is our dynamic model. Our dynamic models continuously update as new data arises, staying current with changing patterns. They require more infrastructure but adapt to distribution shifts. Now our example, real world example for this is recommendation systems that update daily based on new users behavior or fraud detection that adapts to new attack pattern attacks. Now question 35 is the loss function measuring divergence between predicted and true probabilities is cross entropy. Cross entropy qualifies the difference between two probability distribution. It is the standard loss function of classification task in deep learning. Now our question 26 is deep learning is a specialized subset of machine learning. Deep learning is one approach within machine learning, especially using multi-layer neural networks. There the hierarchy of AI is subset of machine learning and where deep learning is subset of machine learning. Neural networks are universal approximators of function. The universal approximation theorem states that neural networks can approximate many continuous functions given enough neurons and layers. This theoretical property underpins their power. This basically means the neural networks can answer to any other data because of the neurons that were given to it. Like it can think also on the basis of the data, and where neurons takes multiple input and gives one computed output, so it looks like a real output. A deep network with more than one hidden layer is termed as deep neural network, where deep neural networks have multiple hidden layers between input and output, enabling hierarchy features during deep reference to the depth of network. Each layer outputs become the next layer's input, where neural networks are sequential. Each layer processes data and passes result to next layer. This creates a computational graph and like and CNNs. What is CNN? CNN are mainly used for image classification. It is mainly for vector also. Convolutional neural networks are excellent image tasks due to their ability to detect spatial patterns through convolutional layers and pooling operations. Like in image recognition, object detection, face recognition, in medical imaging, and RNNs handle data with strong sequential dependencies. Like recurrent neural networks has memory and can process sequentially when order matters and past influence future. They are designed from sequential data like text generation, speech recognition, time series prediction. Now our question 32 is LSTM is an improved version of recurrent network where we will see long short-term memory networks are advanced. RNNs that solve the vanishing gradient problems, enabling learning of longer-term dependencies through gating mechanism. Now our question 33 is in a game the second model act as discriminator discriminator distinguishing real and fake data. Generative adversarial network has two models. The generator creates fake data and the descriptor tries to distinguish real data from fake. Now our question 34 is reusing a pre-trained model for related task is called transfer learning. Like transfer learning uses knowledge from one task to help with another, dramatically reduces training time and update requirements. It is especially powerful in computer vision and natural language prompts. And question 35 is the wide part of the wide and deep model helps memorize specific examples. Wide and deep architecture combines linear models with deep networks. The deep part captures more complex features. Deep layers learn hierarchically abstract features and general patterns from data through multi-level of representation. The deep part captures more complex features because layers learn hierarchically. Now, linear classifier combine inputs with weight and biases to perform prediction. Linear models compute prediction as weighted sum of input plus bias. Now, activation function introduce non-linearity into neural models because activation function enable neural networks to learn non-linear patterns. Without them, deep network would be equivalent to single layer network, where common activations are ReLU, sigmoid, and 10. And adding neurons or hidden layers increase model complexity because more neurons layer increase model capacity but also increase risk of overfitting and computational requirement. Now our question 40 is transfer learning leverages pre-trained features learned from prior tasks. Pre-trained models have already learned useful features from large datasets which can be fine-tuned for a specific task with much less data. Where popular pre-trained models examples are for computer vision as VGG, YOLO, and for NLP are GPT and T5. Thank you everyone. That's all for section C. Let's we meet in section D explanation.